Jared.
I'm Caleigh.
And I'm Cooper. We're here today to show you our Runaway alarm clock. We're part of CSU's Mechatronics 307 Fall 2022 project. And that's basically it. All right, so our problem was when alarm clocks go off, we're just used to hitting the snooze button. So a solution to that was having an alarm clock that runs away from you when the alarm goes off.
We've designed a robot that would go on after the alarm goes off, and once it runs, it would avoid obstacles and you'd have to chase it down to turn off the device instead of having a snooze button right next to your bed.
Hi guys, this is CSU's MECH 307 Runaway alarm clock group. What I'm showing you is the alarm clock function of the whole product. I'll be going over the basic components of the entire alarm clock and how it works. So starting off, we have an Arduino R3 module or microcontroller that's used to power the entire alarm clock. And then we have that connected to the RTC real-time clock, which basically is a chip that uses a small button battery and is able to display the global time within about 30 seconds accurately, even if the power's off. So at the current state it's at right now with no power to the Arduino, it continues to display or would display the correct time. That goes into the Arduino through the analog pins, this white wire and yellow wire, and then uses a ground and power as well. From there, the code is able to kind of take that information and shoot it to the LCD display, which we have here. This LCD is able to display the current time as well as the current date, and then with use of the buttons is able to display the alarm and what time that is set to. This is hooked up to a 10K potentiometer, which is used to change the contrast of the brightness for the backlight in the LCD. Alrighty, next on the alarm clock, we have these 3 buttons. These buttons are connected to pins 12 through 9, as well as grounds. These buttons are used to set the alarm clock function mostly. So if the display was on, the red button would be able to turn on the alarm section where you can set your alarm. The green is a confirmation button as well as a place changer. So one press would change the hours, and then if you press it again, it would be to change the minutes. And then the yellow button is to change the actual value that's associated with the hours and the minutes. And that will all be shown in the demonstration. And then next we have the power module that is connected to the entire breadboard, just to get a little bit more power to the entire thing, as well as help out with our relay. Alrighty, and the next, looking at the back of the 3D printed cover, we have 2 9-volt batteries that are glued to the top. These both provide power to the Arduino and the power supply module on the breadboard. And then what we notice is these 2 wires that come out from the buzzer, that being shown right here, that will go off connected to pin 13 when the alarm is sounding. And those wires also go back to the relay, which when turned on is able to switch the relay on and allow current to run from these 2 wires that are used for demonstration purposes at the moment, but when hooked up to the RC car, are able to turn on that entire Arduino and get that section powered. Alrighty, next I'll give a demonstration how the alarm clock works. First, you plug in your power supply module as well as your Arduino with 9 volts. You get a CSU MECH 307 screen while everything warms up. And then the LCD is able to display the time in military, as well as the date starting from days, months, and year. So to set the alarm clock, first you hit the red button. It's a set alarm clock. You can set up to 8 alarm clocks. And then you can change the hours first by hitting the yellow button. Changes the hours and then resets at 24. So we'll go back to 18. And then you can hit the green button once more to go to minutes. We'll set it to 2 minutes ahead, so at 18:58. Hit the green button once more, and that sets the alarm clock into the system, and then we'll get back. But in the meantime, the potentiometer is showing right now to change the contrast. We'll change that to something a little bit more appropriate, and then we'll get back to you at 18:58. Alrighty, I'm gonna have to work a little bit fast here, but in 10 seconds, the alarm will go off. It'll be a little hard to hear me, but it will show a screen, the alarm will go off, and then you will be able to hear the relay click. So we hear that relay click, we get a constant buzz, which is quite loud. It says wake up. This relay would be open, allowing for the RC car to work and run around, as well as displaying a wake up on the LCD. In order to stop this, you just hit the reset on the board, and it's all ready to be.
For the RC portion of the project, we have a dual H-bridge which sends signal to all 4 of the DC stepper motors, which is then powered by the 11 milliamp hour LiPo battery that is then being attached to the H-bridge and given power to the Arduino. We also then have an echo sensor to determine the distance from an object, and once that object is within that distance, it will give power to all the motors to move in a backwards direction, then stop. Then sending signal to the servo motor to rotate in a left and right direction, while the echo sensor determines which direction has the furthest distance for the H-bridge to send signal to the motors to move in a forward or backwards direction to determine where the RC is turning to. This whole process will continue until it is shut off.
All right, so we're gonna set the alarm now to go into, to play in 1 minute. So we'll hit the green button once to go to minutes, yellow button once to 1935, green button once more, and that sets the alarm to play in approximately 15 seconds. And then what you would do is you'd sit this down like you normally would at the foot of your bed and wait for the alarm to go off. And then when you want to pick it up, and you hit the reset button, and that turns off your alarm, and you're woken up.